see still people are joining, so let's wait 1-2 more minutes and we will start. All right, let's begin. So my name is Michael Batistatos. I'm from Research Center Demokritos in Greece. And today we'll give you some information about our open call. So let me share my screen. Irina, can I share my screen because I see some message? Okay. Do you see my screen right now? Irina, Sofia?
Yes, yes,
Okay.
of course.
Yes.
Okay, thank you. So welcome again. This is the second info day. Some of you maybe have already participated in the first one. So you might hear some things twice, but that's good. As we write in the chat, this session is being recorded, so you can access it later on. If you have any questions during the presentations, please address these questions in the chat, and we have a special session in the end of the meeting to answer them. Or if there is no enough time, we can answer them later on and we will send them via email. So the agenda for today, I will present a little bit the project, and then we'll continue with the TestBed's presentation. So today we will have TestBed number 1, TestBed number 2, TestBed number 4, because the rest of the TestBeds we have already presented them in the first info day. Then again, as we did the previous time, we will guide you to the application platform, and then in the end we have the Q&A section. So Agrarian project is a Horizon Europe project. It has 13 partners, farmers, livestock owners, SMEs, research institutes and universities. And we have 3 pilots in Greece, in Romania, and in Portugal. And the project duration is 3 years. We are now ending the first year of the project. The coordinator is Demokritos, the research center in Greece. Agrarian targets mainly at the developers, at the end users, the farmers, and the policymakers. The main elements of Agrarian are the open source container-based technologies. So we use open source technologies and container-based in order to orchestrate the whole system. We use last mile accelerators because we emphasize a lot to rural areas. So we need these last mile accelerators like the edge computing and the connectivity. And we also provide hybrid communications, both terrestrial and non-terrestrial. So what Agrarian Platform offers? Agrarian Platform offers a dynamic programmable environment for the developers, innovative applications for the farmers, and then we also have a decision support system mainly for the policymakers. And with combined all this, we offer in the end efficient resource allocation and of course seamless connectivity to rural areas, because usually in rural areas we have the farms and the livestock owners. So this is a conceptual diagram of agrarian platform. As you can see, as we said before, we emphasize at the end users, at the developers, and the policymakers. So all these entities have access to our platform, each one with a different role. So the developer enters our system, develop an application for the farmers. He can test it in our system, adjust it, finalize it, and in the end, the developer stores the application in a Dockerized form in our repository. And then, after a time, the end user has access to the repository and can see all the available applications, and he can request for an application, and the system will install and run the application in the appropriate part of the network, suitable and efficient for the end user. So the end user will run the application, will get the information he needs, and part of the information will be stored in this data storage. So later on, the policymaker, through the decision system of Agrarian, can take information from the wider area and take recommendations and suggestions for policies and good practices. In order all this to be realized, we need seamless connectivity, of course, to rural areas, and last mile accelerators like edge computing. So this bottom layer here is also the testbeds, the mainly testbeds of our open call. So hybrid communications and edge computing. So the first testbed, it's about satellite communications. We emulate geostationary satellite communications. Testbed number 2 that we will see today, it's a low Earth orbit satellite communications, both with edge capabilities. Testbed number 3, we present this in the previews, so we don't have that today. Testbed number 4, it's narrowband IoT platform, and especially it's a 5G narrowband IoT platform from Satellite. And we also have a data set. So except from the 4 testbeds that we have available for the open calls, we also provide a data set, especially for the agricultural sector, and you can use it and make your applications. So this is what we provide in the context of the open calls in order you to use it and develop your application. Agrarian, as I said in the beginning, has 3 pilots. And this is important for you because the applications that you will develop must be related to one of our pilots. So the first one is about livestock monitoring in Crete. So there we have a herd of sheep, and we monitoring these animals. The second pilot is in Romania, and it is about field crops monitoring. And the third pilot that we have is in Portugal, and is about vineyards management. Now, what you need to do and what I suggest you to follow in order to have a successful proposal. First of all, we have uploaded and we have public some documents with information about the open call and the overall proposal procedure. So it is very important for you to read the guideline for applicants, the technical annex, and the Q&A documents, all available on our website. So when you go to the platform for your application, you will find all these documents available. We have organized 2 info days. Today is the last one. In case you missed the first one, so that means that you missed the third testbed and the dataset presentation. But still, you can watch the recording. It is available on our YouTube channel. So you can, right now, you can scan this QR code and you can access this YouTube channel. You will go to the playlists, and there you can find the Agrarian and the recording. Also, I suggest to register on our website. So I have a second QR code with our website, and that leads directly to the section where the open calls are. And there you can register in order to receive emails and notifications about the open calls. Of course, if you have any question later on about your submission, we have a support team. This is the email, and you can send whatever question you need. Very important is what to choose from the testbeds and the pilots that I presented earlier. And we have analytical and more detailed information in the documents that you can see above. So you need to choose one testbed or the dataset. You need to choose, for example, one testbed in order there on the testbed to develop and test your application. So either one of the testbeds or the dataset. And then the application that you will develop must be related to one of our pilots. So either has to do with livestock or with vineyards or crops. Of course, you don't need to go to the pilot sites, nor to be synchronized with the date that we will actually make this pilot. The content of your application must be related to one of our pilots. Okay, so I say again, I'm saying that again, you don't need to go to the pilots, just the content of the application must be related to these subjects. And the applications, it's from 1st of this month, so the applications are running, and until the end of January. So these were some words very briefly about our project and the open calls. More details in the documents, or you can ask questions at the support team. I will continue with the presentation of the first testbed. This is a satellite network emulation with edge capabilities. The satellite is a geostationary satellite. It's a special case of a geosynchronous satellite with zero inclination. So the generic concept that we will later develop in the project is hybrid communications. So a use case would be that the sensors, the left side, all this left side is at the farmer at the farm side. So we have the sensors, we have the user, and all the data can either go through the satellite network or through the terrestrial. It will be a 5G network. Depending on the situation, on the conditions that we'll have in the farm. So we have two options for the data in order to have seamless communications. If the terrestrial network is not adequate or cannot serve that time, we can go to the backup plan, which is the satellite network. And then we have access to the internet, and also the user can either be in the farm, on the site, or somewhere else, maybe in his office, in his house, and access the data from the farm from his home. Here in this architecture, the application server must be can be in several places. The classic method is to be on the cloud, but this is something that we don't want in the project because, as I said before, we emphasize in the last mile. So we take the app server from the cloud and we install it close to the farmer. The best case scenario would be to be in the farm, but this has a lot of challenges and limitations. So other alternatives and still be on the edge is to have the applications and the edge server application on the satellite, and we have a testbed for that. At the ground gateway of the satellite, and again we have a testbed for that, or in the core, at the core of the 5G system. So for that open call, for the first open call of Agrarian, the first testbed is that case. So we have a geosatellite emulated network, and we have the edge application server at the ground gateway. So again, the server is not on the cloud. It's near edge. It's not completely at the edge, but it's near edge. And the sensors, the data of the sensors are directly connected to the ground terminal. The user is connected to the internet and can access the results of the application through the internet. So the path is, and what we try to implement in this testbed, first is to have the edge, the application at the edge server here at the ground gateway, and the data to pass from the ground terminal to the satellite and down to the ground again and to the application. More analytical and in relation to you also as developers. So here on top, it is the platform, the testbed of Demokritos, the first testbed, the satellite emulation. Actually, all this, it is consisted of three nodes, the ground terminal, the satellite, and the ground gateway. The ground gateway is connected to the rest of the internet. And all these nodes here are VMs and emulated entities. So at the bottom, it is your side, the developer side. You can have some sensors or maybe not. So how you will be connected to our testbed? We will implement a VPN connection. So you will be connected to our platform with a VPN. So you will be connected through the VPN to our Edge server, and it is there that you will install and test your application. In case you have some sensors, then again with a VPN or with another way, you can see that the data must be ended up at the ground terminal of our emulator in order then to travel, to go to the satellite and then back to the Edge server where it will be consumed by your application. Then the results of your application, for example, the results of the inference, if you run an inference model, will be exposed to the internet because, as I said before, the Edge server is connected to the internet, will be exposed to the internet, and the end user can access them. So again, this is the application node, and this is the data node. In case that you don't have sensors and you have some other kind of data, you can directly store the data here. What we care most is that path, so the data must be passed through the satellite link. The challenges in this case, in this use case, is that this satellite link introduces a propagation delay. So for a geostationary satellite, which is almost 36,000 kilometers from Earth, from the surface of Earth, this is the propagation delay, 215 milliseconds, one way. Of course, the data rates are not infinite, it's limited, so you need to get that into consideration. The sensors, in case you have sensors, you need to develop the technology in order the sensors from the farm. So you will have the sensor in your farm, in your office, in your site in general, must be transmit the data to our testbed. So you need also to develop that path. And finally, when you develop, test your application and everything is ready and work fine, you need to store this application in a Dockerized form, because as I said before, all the applications, the Dockers, will be stored in our repository in order then our system to handle them. So finally, we will accept Dockerized applications. So this is all about our first testbed. Of course, in case you have questions, you can write them in the chat, or later on you can send an email to the support team. Of course, the winners of the open call that will choose this testbed will have some support and will be in communication in order to finalize the whole setup and finally to have a good application. So this is all about me. Now I will give the floor to the next one. Who was the next one? I think I will go to the agenda in the beginning. Okay, it's Tommaso from DLR.
Sorry, Michalis, to interrupt. You have questions
Yes.
in the chat if you want to address them. Have a look.
Okay, so Tommaso, the floor is yours. Thank you very much.
Okay, so good morning, everyone. I'm Tommaso De Cola from the German Aerospace Center, and I'm going to present the second testbed of the day. Just a second that I'm taking the presentation. I hope you can hear me and see the first slide of the presentation.
Yes, Tommaso, everything is good.
Okay, so this testbed is somehow pretty much aligned with the concept that was just presented by Michele a few minutes ago. The main difference is that here we are addressing non-geostationary satellites that, in a few words, are LEO constellations that are onboarding edge capabilities, and as such may feature some important differences with respect to the previous one for what regards to the fact that we are going to experience lower latencies since LEO satellite orbit at lower altitude, the range between, say, 300 up to 2000 kilometers, so that the latency is in the order of some tens of milliseconds maximum. And on the other hand, however, the satellites are not fixed in sky with respect to the ground user, differently from geostationary satellite. And because of that, the visibility of a given satellite varies over time, and as such, the access to the overall transportation network in space is not continuous unless the interconnectivity between neighbor satellites in the form of the so-called intersatellite links is exploited. And this is pretty much what our testbed is capable of offering. If we have in mind a general network architecture where on the left-hand side, say the IoT-based application for supporting smart farming services. In between, we have then the actual network access that can be composed of terrestrial or satellite counterpart. And then the last mile is on the right side is the cloud node by the white. As a matter of fact, the testbed provided by DLR, that is the one enclosing this yellow hexagon, is pretty much focused on the satellite part, so that the satellite testbed will be able to kind of characterize the main capability of a satellite constellation. Of course, we don't need to feature a large constellation as nowadays is often reported on press release, journals, and so on, like I don't know, Starlink and so on. Here it's more about a lower number of satellites, because in the end, what is really needed for the purpose of an IoT service achievement is just to have a few satellites available for a certain amount of time. And obviously, as I said before, there is the fact that satellites are not always in visibility, and as such, some application might go through neighbor satellites. Each satellite, more importantly, is equipped with specific edge functionalities that are more like a modelization of real edge capabilities. And as such, the role intended for users going to access this testbed is, on the one hand, obviously to attach their application externally to the testbed and accessing the testbed itself by means of a VPN and dedicated graphical user interface, and then later to recollect the final results either directly through the graphical user interface or by exporting the results offline and then obviously making the necessary results. As a matter of fact, the testbed, as every testbed dealing with the network performance is composed of a number of steps for what regards the scenario configuration, because as a matter of fact, we will be able to offer the user to configure as much as possible the characteristic of the network you'd like to use, or the characteristic of the edge functionalities desired. Obviously, there might be a number of features that could be either directly configured by DLR operators, that could be dealing, for instance, with the satellite network definition and configuration, that is the top part of this diagram, while the other two, so the configuration of IoT node and edge nodes, that is something peculiar of the specific agricultural application being considered, could be something to be done up to the external users. Nevertheless, DLR operators will be available for supporting this and all the other operations, and making sure that the testbed is completely fulfilling the needs of the interested users. Once the configuration is complete, there is the simulation part, so that the simulation can be run. And then at the end, there will be the extraction of the main results in the form of selected KPIs in order to carry out necessary post-processing and finally draw important conclusion for what regards the collected results. As a matter of fact, this testbed is pretty much related to the capability of performing edge computing in space. So that, as said, there are dedicated agents implemented on board the emulated space network, so on board the satellites, in a few words. And a key aspect, obviously, is also dealing with the IoT generation, so that currently this is being done by means of dedicated mathematical models, but the objective is to possibly plug external agents offered by the developer, developed themselves by the external users, so that the data there generated will be transferred, for instance, by means of VPN through the DLR testbed, and then transiting throughout the entire network. And this will then eventually give some result in terms of the overall latency necessary to perform such operations, and other relevant KPIs depending on the specific needs of the users. And then, as such, just to conclude, it's important to point out what could be the main aspects that could be further introduced in such a testbed. On the one hand, there is the part related to the IoT, that means the definition of specific IoT modes and related integration from a development standpoint. Then there is the actual usage of real devices that could be virtually interconnected to the testbed, and I mean virtually in the sense that, of course, there is no need to actually move the real device where the testbed is collocated. That means by DLR, the device could be interconnected to the testbed by means of established VPN, and then obviously by means of dedicated configuration module, as shown in the previous slides, we'll be able to run the proper simulation and then extract the key performance indicators. Last but not least, since one of the main objectives of the project is indeed to show the potentials of edge computing to favor kind of advanced performance of smart farming services, we have the edge computing in space, for which dedicated client server could be deployed. In such a case, it's either about extending the already existing functionalities that are mostly model-based in the testbed, or even directly plug real instances coming from the developers that could be either running directly in space or possibly also in ground, or even in a mixed approach. Then the selection of the specific edge computing facilities will be carried out on the basis of the optimization algorithms that are available in the testbed, that are based on kind of some heuristic, so some suboptimal decision tools, or by means of some advanced artificial intelligence-based algorithms. As said at the very beginning, the testbed will be accessible by means of a dedicated VPN. This is mostly for integrating new functionalities and performing some initial tests. And then obviously for loading configuration files, running the simulation and eventually collecting all the results, there will be a dedicated graphical user interface in order to facilitate the access and to make the overall operation more user-friendly. That's all from my side. Thank you very much for your attention. Of course, if you have any questions, please write them in the chat. Thank you.
Okay, so let's continue. We have the next testbed from Satellite. So, Sergio?
Hello, can you hear me?
Yes, yes, and we can see your presentation, but not in the presentation mode.
Now?
Yes.
Excellent. So, hello, welcome everyone to this Info Day. I'm Sergio Aguilar from Satellite, and I'm going to present with Shuham, our SEED 5G SpaceEdge AI-enabled delay-tolerant narrowband IoT platform that we are preparing for this agrarian project and for the open calls for the different developers to participate. As you may know, Satellite, we focus on connectivity where this connectivity is not available. As you know, 10% of the world is connected with mobile networks, but there is a need for this 90% of the world that doesn't have connectivity. In this case, we have users like farms that are located in rural areas. We have also the open seas and many other areas where connectivity is not available. So we focus on extending coverage for current mobile network operators to provide coverage where they currently do not have. So we can enable use cases like in this case, farming and in open seas, assets tracking and many other use cases. In this way, we can provide a seamless and affordable 5G narrowband IoT connectivity from space. We are the first 5G mobile network operator in LEO for IoT. And we work with 3GPP standards, and this is important because we work with interoperability. We use a unique scalable store and forward technology that is especially focused for delay-tolerant application. In this case, the satellites pick up the data and then they are forward to ground when connectivity is available. This way, we can provide service with our 4 satellites that are already launched in the past August, and we hope to go commercial starting next year. Now going into the goal of the testbed that we are providing on this and developing on this agrarian project. The goal of the testbed is to provide IoT devices with, well, you know, IoT devices have limited capabilities. So the idea is to offload some tasks to satellites with the objective of extending the lifetime of these IoT devices. This way, only relevant data is forward to ground, and most of the data can stay processed on the satellite. With this, we can reduce the bandwidth that is needed for these links that connect the satellites to ground. In this testbed, we emulate the IoT connections to the satellite. So we hope we can validate the code for readiness for deployment in space. And at the end, the idea is to provide this analysis of agricultural data directly from space, such as crop health or weather patterns, and with the idea of enabling a timely decision making without relying on ground stations. The idea is that the satellite is able to provide a response to the IoT device immediately. Therefore, there is no need to go to ground, so the delays of this communication can be reduced. Going into our testbed architecture, in this case, we simulate a sparse LEO constellation offering narrowband IoT services. This includes no real time for end-to-end connectivity with the inherent delays that you will have in LEO, and in our case, with the store and forward technology. Our idea is that the open call developers can upload, for example, a Docker image to the IoT application repository to the CI/CD pipeline, deploy applications on the satellite and or in the IoT device with the objective of implementing IoT application to manage available on-premise sensors or dump real data measurements on the IoT device to emulate real-world data acquisitions. In this case, what we have as an IoT device, well, we are proposing to use a Raspberry Pi with a Raspberry Hat. So we will have available humidity, temperature, and pressure sensors. So one way of having the data is using the data that these sensors provide. Other ways of having this data is to provide a data set that can be fed into the IoT device. So with all the experience of the open call developers with their sensors gathering information, you can provide a data set that is then timely sent, simulating that the device is connecting and actually having this data, but at the end it's a data set that is previously configured. In our case, we are focusing on the edge computing side. Part of the AI that we can have in this testbed is provided by the Robotica's Rupia application testbed that was already presented in the previous info day. So in this case, we are mostly focusing on the edge application side. We will provide the open call developers with a VPN so that they can connect to both the IoT application. Depending on how we manage, I have some slides forward, the way we can provide some connectivity to the satellite emulator platform. And the idea is that at the end, you are able to have, if required, end-to-end connectivity. So you will have the IoT application server on the other side, where you can forward data on the end-to-end, and then some data will stay on the edge on the satellite for processing. Some key application requirements we see, we will be needing a README file for the details of the purpose of the application, programming languages, and deploying target, if this is the IoT device or the satellite, and the input and output data formats, depending on how you think. Of course, we will have always support from the R&D team from Satellite for this. So at the end, the objective is to have this Docker file or Docker image, right, on a container that we can deploy on the different platforms, the IoT device or the satellite. Some of the test environments requirements that we have is we have to ensure that the application is compatible with, in case of the satellite, a 4G 4 gigabits RAM and an ARM-based architecture. For the IoT device, we see a 2 gigabit RAM with the ARM-based architecture. The runtime, in this case, the OS is a Raspberry Pi OS. We are using Raspberry Pis in our testbed to simulate the different devices, not the communication. The communication will be done using modems, narrowband IoT modems. We have the satellite that can connect to this device. So all the part of connectivity is emulated from real hardware that we are providing to the project. At the end, the idea is that you are able to push your code to a Git repository, and from there we can manage to do the deployment, of course, with all the collaboration of the open call developers. here we have an example of what we envision, how this can be done. Many of the I also forgot that in the test environment, the transport protocol that we use is UDP. So the idea is that, for example, if you need to develop the application, you can do a UDP tunnel from the IoT device to the edge application. This way you can connect your application, and then this UDP tunnel will be substituted by a UDP tunnel over the narrowband IoT system, over the satellite communication with the IoT device. This way, we believe that the developers can develop on-premise their application using this consideration, and then once the application is ready, we can pack it as a container for a Docker deployment, and then we can deploy it in our system. So, sorry. So the idea is the open call will have an interface, for example, a JIT command line or a website where they can share the repository. Then we are actually developing this CI/CD pipeline for this containerized code to be produced, and then we will have this Docker image registry where Kubernetes or any other application, we will start probably doing a manual deployment, but while we develop all the chain in the project. So the idea is that the Kubernetes environment will deploy these Docker images depending on where they are chosen to be deployed. This can be on the 5G narrowband IoT satellite node or in the IoT device node. Some of the how we see this data, how we can input data to the system and retrieve results. In terms of the data input, as I talked before, we have two options that we see. We have some on-premise sensors on the device, more focused on temperature, humidity, and pressure. That are the ones that we have available. So these sensors, you can grab information from these sensors, but also we believe that a more probably a real way of implementing this is using emulated real world data. That is data that the open calls developers can find on the different sensors on the field. So once we have these data sets can be fed into the IoT device data storage, and then this data will be timely sent over the network to simulate that the sensor is gathering real data. Going into the output data, we see that you can have this edge application on the satellite. So maybe you will need a command prompt or a terminal where you are able to see the execution of the application, where you see that for example, if there is a humidity, soil humidity sensor on the field, and this goes over some thresholds, and you need to start the watering of this area for a period of time, then probably on the command prompt you can see this happening. Also, if you need to access some logs or some other information that is output in your code from the container, we will be making this information available through a drive or some kind of data sharing information, so that you can have, after executing the test, you can have all this information available. Going to the takeaways at the end, well, the IoT simulations, our testbed replicates IoT connections with satellite, ensuring your code is validated in this case. For the code submission, we are working on this JIT repository. So at the end, this make agnostic the programming language. You can program in different programming language, because at the end, we will be doing this containerized version of the code that we can deploy on the IoT device or in the edge satellite, or in both, because at the end the application needs to have the two parts. Then you can provide your own IoT server application where you can connect to our system and see the data flow from the IoT device to the IoT server with all the pre-processing done in the edge. We are working on a deployment pipeline for this so that this can be automatic. Probably when we start, if we don't have this ready, we can do the deployments and work together on that. We have two options. You can use the sensors that we will have available on this IoT device, but we believe also that if you have some real data so that we can emulate these applications and in this data series of information, we can also work on that. So at the end, and the results, you can access the results in the command prompt where you are executing in the IoT device, or if you need access to the edge applications to see everything is working, we can also provide this access. And we, via VPN, you can access these both nodes, and also via VPN, we hope that we can provide a connectivity to let's say the mobile network that we have, so you can have your data on your IoT application server. So this is all for me. I said here questions, but I believe that we will be answering the questions. If you have any questions, please, we will be happy to respond. Just leave them on the chat, and we will get back to them. And thank you very much for your attention, and I hand it back to Michael.
Thank you, Sergio, for this very nice and detailed presentation. Now we will continue with a walkthrough to our platform that you will use in order to submit your proposals. So Konstantinos from Demoktos is going to present that. Konstantino, the floor is yours.
Hello, everyone. My name is Konstantinos, and the purpose of my presentation is to show you how. Can you confirm that my screen is shared?
Yes, you can see.
Okay.
It.
Okay. So for submission, to submit your proposal, you have to go to our platform in the domain agrarian.appliobox.gr. When we first visit our webpage, we see the login form, and we have to make a registration and create an account to use the platform. Here we can find the link, register here. And then we have to fill the form with our data, and we set the password that we want to use for the platform. We click register, and the verification email is sent to our account. Here is the email that you will receive in your email account. We click verify your email, and then you are redirected again to the Applio box. And now your email is verified, and you can log in to your account. Here in the login form again, we fill our data, password, email, and our password. And now we are successfully logged in to the platform. In the first page, we can see the agrarian call that is now available and open for submission. If we click more info, we're going to details about the call, the due date for the submission, and we can see an overview description about the call. And down here in this section, we found in conditions document section. We can download all the documents related to the call, applicant guidelines, technical annex, and download FAQs. Those documents will help you to submit your proposal and fill the following field data. Okay, now we click apply. And now it loads the form for the proposal with the sections. Here in the basic info, we fill all the required data. Be careful to fill the testbed that you are interested in, and the pilots. Here is a self-assessment. In this section, you have to download the template file, the templates for the proposal form and the SME declaration if needed. It's a zip file that you will download the two templates and must be uploaded as PDF. More down, it's the eligibility self-declaration. There are some questions that you have to answer. And at the bottom, we click confirm and legally accept, and then we press the save draft. Now your proposal is saved as a draft in our system. And to be a successful submitted, we have to finalize our proposal by clicking sorry, on the top of the submit button. And when we click submit, you can see the last submission date and the flash message that your proposal was submitted. After that, an email is sent to your account for the confirmation of your final submission. And now here again in your account, you can see your proposal, and you can do this procedure again as many times you want until the due date of the submission. And in the last section, there are some FAQs. And finally, we have a functionality as regards if you forget your password. There's a functionality to recover your password. You put your email here, press reset password, an email is sent to your account. You press reset, and here you can recover your password. That's all for me. Thank you very much.
Thank you, Costa. And now we have some time for questions that we can answer. I mean, the questions that have been written in the chat. So we'll go very fast through them. As I can see, most of them have been already answered, but I will go very fast and I will say some words about them. Milenko asks about if we need to take into consideration the geographical and regional requirements of our specific use cases, for example, Romania, Portugal, and Greece. No, just your application need to be related with the content of our use case, not you don't have to take consideration regional specific requirements. It's not the case. Second, from the same person, second question, if the application needs to run at the edge server, or it's possible to run somewhere else, or to be combined with another platform somewhere else in the cloud. What we need is that the application and the computational power of the application to be at our edge server. Now, if your application needs to be connected somewhere else for a function, it is okay from us, since there is no any special requirements and issues. But the main computation effort of your application must be on our edge server. Next question by Micha. If the application must be limited in our use case, which is the sheep herd, or could be related to other livestock, to other kind of livestock, like bees or whatever animals. Yes, you can have other cases, like for example, bees that you are writing, as long as you can demonstrate your application. So if you have an application with bees or with cows, then you need also to have the related material, the bees, the cows, in order to validate and demonstrate your application. Other question, it's about, again, TestBed 1 from Giancarlo. To tell you the truth, I don't have the complete picture of your idea, but as long as you have an application that you can install it and test it and run in our edge server, and not only that, you also need to have some data, sensors that produce data, or a ready data set that you need to place it to the other end of the network. So for sure we need the data to travel through the satellite and end up to our edge server. Yes, you can propose this solution. Tommaso from DLR answered the question about TestBed 2. The recordings will be available in our website. In the beginning, I gave you the link directly to the YouTube channel, but also we are uploaded them also to our website, so it's very easy for you to find them. We have also questions for the last testbed, and Sergio very kindly answered it. There is one more question from Nikos that I haven't found the time to review it before I open my microphone. So Nico, I will read it, and right now, let's say we have a smart farming solution for pest management in vineyards based in multiple IoT sensors in the area, but has now no internet connectivity. Can you explain what is the difference between the three test beds on what they can offer us? Do you mean so you need the difference between the three test beds? The first test bed offers connectivity through a geostationary satellite with all the challenges that this system brings. So, for example, very long delays, maybe limited bandwidth. The second testbed is about connectivity. I'm talking only with the connectivity, not the edge part, since you are talking about the connectivity. The second testbed gives connectivity with low Earth orbit satellites. So now the delay is significantly less. And the fourth testbed of the project, but the third that we presented today, gives connectivity not with the classical satellite protocols. So, for example, in the first testbed, the protocol will be DVB-S2 for the downlink and DVB-RCS for the uplink. But it's not that the case in the last testbed, because there the connectivity is realized with narrowband IoT technology. This is a new technology, especially when it's combined with 5G systems. Maybe Sergio can answer more on this. Sergio, would you like to tell how your testbed offers connectivity for an underserved area?
Yes, in this case, our testbed is focused also in, let's say, real IoT devices in the terms of the modem and the connectivity to the satellite. This is something we are emulating in our system. So current we will be using certain modems. That was something a question that was asked there, and so the idea is that we are able to connect with actually connectivity, the narrowband IoT link from the device to the satellite. In this first step, we will be using platforms that emulate the satellite, like, for example, Raspberry Pis, but then we will have the front end that is the actual satellite, the actual core network that is a replication of the things that we use on our operation system. So at the end, you will be simulating real connectivity. We also have emulations of the discontinuities of the link and how this connectivity is managed. So yeah, we're using this narrowband IoT solution that is based on a standard, and we will be providing the modem, but we can talk, answering the question there also, if we can put other kind of modems, but at the end, we are focusing on this containerized application that you can deploy on both edge, let's say the edge on the device and the edge on the satellite. I hope I make it clear the question.
Thank you, Sergio. In case they have more questions, they can send to the support team. So for that, the main difference is that in the first case we have a very classical setup, the classical geostationary satellite that it used for communications. In the second case we have the low Earth orbit, so then we have a lot of handovers and things like that. And in the second one, in the third one, we have a completely different setup. It's a narrowband IoT. So yeah, so this was it, the last info day. Thank you very much for participating, and we're looking forward to your very interesting proposals. Thank you very much, and have a nice Christmas.